Hello, everyone. Hope your day is a wonderful one today. Let's move on to two more congruence criterion from this chapter. In the previous periods, we have seen what is SAS congruence condition, which means two sides and the included angle. The next one we saw was ASA congruence, which can also be written as AAS. But here we can't write SSA, can't be written. These were the two congruence criterion that we have gone through before. Now let us see the third congruence condition, which is SSS congruence condition. This is a much easier congruence rule because we just have to see three sides. Let us see. If three sides of one triangle are equal to three sides of another triangle, then the two triangles are congruent. Let us see with shapes. Here we have two triangles, PQR and ABC. These two triangles are congruent if you have three corresponding sides of these two triangles. If they are equal, then these two triangles are congruent. And how do we write? Triangle, as we said, the first triangle, we can write it in any order, no problem. First Q or first R, congruent to triangle. The second one, we have to be careful. PQ is compared by one cross line, which is with AB. So A, B, and the last one is, or the next one is QR, which is BC. So B with C. These two triangles are congruent by SSS congruence criterion or SSS congruence rule. And the last one, there is one more congruence rule, which is called RHS congruence rule. This is also very easy, but the problem is it should be in a right triangle. R stands for right angle. So this should be in a triangle with one angle 90 degree. So in a right triangle, if the hypotenuse and one of the side is equal, then triangles are congruent. Let us see. If in two right triangles, hypotenuse and one side, we need H and S, of one triangle is equal to the hypotenuse and one side of the other triangle, then they are congruent. Here it is. These two triangles are right angled at M and Y. Now, we can say these are congruent if one of the sides, let's say LM and XY, it can also be MN and YZ, any one of the sides, and the hypotenuse. Hope you remember the word hypotenuse from small classes. Hypotenuse means the side which is opposite to 90 degree. We have the 90 degree, the side opposite to 90 degree is here. So if the hypotenuse of both the triangles and one of the side of both the triangles are equal in two right triangles, then the triangles are congruent by RHS rule. This is also called RH rule in international system. They may not refer to the letter S, but this is specifically RHS or simply RH. So let's write down what is the triangle. As usual, we can write the first triangle as we like. LMN is congruent to LM, which is XY. Triangle XYZ under RHS congruence criteria. Now let us see some examples related to SSS and RHS congruence rule. Here we are given P and Q are equidistant. Equidistant means equally distant from A and B, which means side AP is equal to side PB. And QA is also equidistant, which means side AQ is equal to side BQ. Since we are given these two sides, we have to consider these two large triangles, which is PAQ and triangle PBQ. In these two triangles, we can see that side PA is equal to PB and AQ is equal to BQ and PQ is common. So AP is equal to BP. It is given to us, so we get one side. Now AQ is equal to BQ. It is also given. We get the second side. Side PQ is common for the green triangle and the brown triangle. So we can say PQ is common. So we have the third side now. So by SSS congruence, we can say that triangle APQ is congruent to BPQ. APQ congruent to triangle BPQ. Since the green and brown triangles are congruent, by CPCT, we can find that angle APC is congruent to BPC. So we can say APC is congruent or equal to angle BPC because they are corresponding parts of congruent triangles. Now we get these two angles are equal. Now the question is to prove that AC is equal to CB. So we have to consider the small triangle APC and BPC. From this triangle, from triangle APC and BPC, we can see that AP is equal to BP. It's given. So we get a side. Angle APC is equal to angle BPC. We just proved it above, from above. So we get one side, one angle, and you can see PC is common. So we have one side, one angle, and another side. So by SAS congruence rule, triangle APC is congruent to triangle BPC, which means AC is equal to BC. What is the reason? Corresponding parts of congruent triangles are equal. So we can see that PQ bisects the side PQ bisects AB. We also know that angle PCA is equal to angle PCB, again CPCT, because those two triangles are congruent. At a point, if two angles are equal, which means each one of them will be 90 degrees. So we can say, therefore, angle APC is equal to 90 degree, because at a point, if two angles are equal, then they are 90 degree each. So finally, we found the answer that PQ is a perpendicular bisector, because first we have proved it is bisector. Now we proved it is perpendicular. So together we can say perpendicular bisector. Of AB. Let's move on to one more example. P is equidistant from lines L and M. Equidistant means, these two sides are equal. And distance refers to 90 degree. These two angles are also 90 degree. Now the question is to show that AP bisects the angle between them, which means these two angles are equal, we have to show. So we have to take the triangle ABP and ACP. So in triangle ABP and triangle ACP, we can see that angle B and angle C are 90 degree. Angle B is equal to angle C 90 degree given, because it is distance, so it will be always 90 degree. So we have a right triangle now. Now the side opposite to 90 degree is called the hypotenuse. So AP is common. Which means we have the hypotenuse now. And the side BP is equal to CP, it's given. So we have one side. So by RHS, the triangles are congruent. Which triangles? ABP congruent to triangle ACP. Which means the corresponding angles, which is BAP, angle BAP is equal to angle CAP. The two angles are equal, which means this line is bisecting the angle. So the line AP bisects the angle A. Hope it's clear. That's all for today, and we will do the exercise in the next period. Have a wonderful day.